Hey everyone. So we have one more notes. It's actually the last one for this section, lesson 1.2c, and this is covering two topics: angle addition and angle bisector. Okay, so go ahead and put that down. And then an angle bisector, that is a ray that divides an angle into two congruent angles. So it's a ray. And what it does, now we have defined bisect before. Bisect means cut in half. So what we have is a ray that divides an angle into two congruent angles. Okay? And then remember from the last section, I know this angle is congruent to this angle because of the markings. Right? And then let's call this CD. So ray CD is the angle bisector. Because it's cutting this angle into two equal angles or congruent angles. Okay? So ray CD is the angle bisector. When we were talking about segment addition, a segment is bisected into two equal parts by the midpoint, right? Okay, so that's angle bisector. And then the next thing we have on here is, I'm just going to lower it a bit, is angle addition. And this is similar to the segment addition, only we're talking about angles and not segments. So it says if a point D is in the interior of angle CAB, then the measure of CAD plus the measure of DAB will equal the measure of CAB. And I know that sounds like a lot of rubbish. But all they're saying is, imagine this big outside angle, right? Which is CAB. This is the big outside angle. CA and then B. All they're saying is that big angle will equal these two inside ones. Okay? And I put different marks on them because they may be different angle measures. So they have different marks, and I do have something to kind of explain this a little bit better. So here we have the measure of CAD, angles CAD plus angles DAB, and that should equal the big outside angle CAB, right? And everybody likes pizza. Hopefully everybody likes pizza. So I'm going to use pizza slices. So that first angle, right, which is CAD, you can tell just it follows the letters, plus the other angle, which is angle DAB, right? So we have those two pizza slices equals the big angle. So imagine it's just like take the two pizza slices, put them together, it makes a big pizza slice. Same thing with the angles. Take these two smaller angles and put them together, and it's going to make a bigger angle. Right, so that angle plus that angle equals the big angle, and the big angle, I did change the color there, you can see is CAB, and that's all they're saying. The two angles put together make the big angle, or the two pizza slices put together make the big pizza slice, and that's angle addition. Okay, pause it, record this, and I'm going to do some examples now. Make sure you copy this. That's what I meant. Pause it, copy it. Okay, let the light adjust. Oh, come on. Stop. Okay, there it goes. So then for these examples, it says, use the angle addition to find the measure of the missing angles. Okay. So here we have a diagram, and then they tell us angle EFH is equal to 96 degrees. And what I like to do is I like to put where these, what this measure equals inside the angle, so I know which angle it's talking about. So EFH, if you follow the letters again, see here's E, F, and H. So I know this inside angle is EFH, right? And then it says HFG. HFG is this other angle, and that's actually the one we're looking for. And see, these are the two inside angles. So the two inside angles are going to equal the big outside angle. It meant just like our two pizza slices, it's going to make one big pizza slice. And then the one big pizza slice is EFG. So EFG, EFG, it goes from E all the way to G. And that guy equals 130 degrees. Okay? Well, to find this or to figure this out, it's actually pretty easy. I know the first angle is 96 degrees. I don't know what the second one equals. And then the third, or the big angle, equals 130. All I need to do is subtract these two. And actually, I haven't done it, but let me do that now. So 130 minus 96. So this inside measure is 34 degrees. Okay? So I know this one is 34 degrees. And again, the important, oh man, my paper's all over the place. Sorry about that, guys. The important thing is these two angles equal the big outside angle. Okay? And that's all the angle addition postulate is. So let's go on to the next one. Again, here's BCE equals 95 degrees. Angle BCE equals 95 degrees. So here's B, C, and E. So I'm going to put my 95 degrees in here. And then the other angle they give me is ECD. Here's ECD, right? ECD. So I know this one is 65 degrees. So from here to here is 95. And then from here to here is 65. And then BCD. BCD is the big outside angle, right? Well, that one's easy. All I need to do is take the one inside angle, add it to the other inside angle, and it'll give you the measure of the big outside angle. Okay? So I'm going to go ahead and add those. 95 plus 65, and we get 160 degrees. So I know that big outside one is 160. And again, it's these two added together give you this one. Just like these two added together give you this one. Okay. So that's the first. We'll be doing some of that on today's assignment. You can pause it right now. To copy that, I'm going to erase it so we can get the last example in here, all of it. Okay, so there's the last example. Go ahead and copy that. Pause it right now, that way you have time to copy it. All it says is ray BX is the bisector of angle ABC. So the first thing, I'm actually gonna put this information in here. So they're saying this ray BX is the angle bisector of ABC. So right off the bat, I know this angle, whatever it equals, it's going to be the same as that one. Okay? They're equal. It's an angle bisector. That's the definition. Look to the left. It tells us. So then we're going to move on with the information. If the measure of angle ABX is 5x, here's ABX. So again, I like to put the information inside here. And then the measure of CBX, here's CBX. See, CBX is 3x plus 10. Find the following measures. So I want to figure out what x is. I want to figure out what the measure of ABC is. And to find the measure of ABX. So I'm going to find all those angle measures. Okay. Well, this is how we do that. Because BX is a bisector, that means it cuts this big angle into two equal angles. Now hear what I said. 2 equal angles. So I know the one angle equals the other angle, right? I know ABX is equal to CBX. Plus I put the marks in there. So I write the equation, I can solve for x, that's going to be x, then I can find these other ones. Okay? So here, whenever you have a variable on both sides, you should think, eliminate one of them, usually the small one, but it doesn't have to be. But I am going to eliminate 3x. So I would write minus 3x to both sides. 5x, take away 3x is 2x, bring down the equal sign. 3x minus 3x is 0. 2 times x equals 10, divided by 2 divided by 2. I'm not going to write it, but 10 divided by 2 is 5. So I know x equals 5, right? And then it says find the measure of ABX. Well, I know ABX is 5x, right? It actually even says up here, the measure of angle ABX equals 5 times x. And I just figured out what x was. X is 5. So if I multiply these two, 5 times 5, I get 25. And it is degrees. That came up a couple lessons ago. Angles are measured in degrees. Okay. So then it says find the measure of ABC. ABC is the big one. Well, we just figured out that this is 25 degrees. And because these two are equal, I know this also equals 25 degrees. So the big one is this angle plus this angle. 25 plus 25 is 50. Okay? It's the one pizza slice plus the other pizza slice equals or makes a new big pizza slice. Okay? And that's it. Pause it. Finish copying it. You guys have a good day.